Okay, these next two questions are about graphing. And to be honest, we should never miss graphs since we have graphing calculators. So we should exploit that as much as possible. But there are some things you should kind of know before you even get started, such as the end behavior. You'll probably already know the domain and the zeros. That's pretty easy. You don't need a calculator for that. So the end behavior, if you count up the x's, there's 4 x's. So that means this is an x to the 4th problem. So that means that because it's an even exponent, the end behavior should match. Since there's a minus in the front, that means that they're both down, down. So right away, before we even start graphing, we already know the end behavior. It's negative infinity and negative infinity. We should also know the zeros. The zeros are the opposites of what's in the parentheses because they've already been factored for us. So there's going to be a 0 at -3, -2, +1, and -1. So those are our zeros. And let's see, domains. When we do polynomials, the domain is always negative infinity to infinity. The only time you don't have that is when you have radicals involved or, I don't know, square root. Those are the only two I can think of right now, for this class at least. And let's see what else we got here. Oops. Yeah, everything else we're going to need to sort of at least plot on the graph. So it says sketch. Sketch means it doesn't really have to be perfect. So we could jot down all of the zeros. I don't know where this 1 went. It's supposed to be a 1 right here. So we have a 0 at -3. So here's -3. We have a 0 at -2. We have a 0 at -1. And we have a 0 at +1. So we already know we're going to have dots on here. As far as the other stuff, we could go to the graphing calculator for that. So I'm just going to type in exactly what I see. Negative parentheses x plus 3. And a second parentheses with x plus 2. Third parentheses with x minus 1. Fourth parentheses with x plus 1. So let's see what we got here. The graph kind of does this weird wavy thing, but I'm gonna be a little bit more exact, and I'm gonna actually find like the maximums and minimums by using the G solver. So I go into G solve and go to the max. It tells me that the max is found at -2.6 and +1.3. So if I mark this off, -2.6 is a little past halfways. -1.3 is a little bit above 1. So that's our maximum. There's a second maximum. It's at 0.3 and 6.9. 1, 2, 3, 4, 5, 6, 7. So 0.3 and 6.9 is just under 7. And then it also has a minimum. So I go back to G-solve and I go to the minimum. The minimum is 1.4 and 0.9, negative. So there's -1, 1.4, -0.9 is probably around right here. So as far as the shape goes, it goes like this, comes back down through here, goes back up, and then comes back down. Now, I probably should have been writing all this stuff down because we need to know the maximums and minimums. So that's a minimum that we have here. So it's at -1.46. I'll put 1.5-ish, just round it off. And -0.94, so -0.9. So there's the minimum. Now I'm just going to go to the G-solve, go back to the maximums. There was 2 maximums here. And so the maximums are at -2.6, 1.3. I could make that a 4 probably. And then the second maximum was at 0.3 and 6.9. So let's see what else we got here. Increase and decrease. So increase and decrease, we basically use the numbers from the maximum. This is where it changes directions. So this is where it changes directions, and then this guy right here is where it changes directions. So for the increasing is going to go from negative. Let me speed this up just a little bit. It's going to be coming from -infinity. And it's going to stop at the first maximum. The first maximum was at -2.6. Then it's going to start up again, start going up. At the minimum is at -1.5. So the graph goes up until the maximum. The maximum is at 0.3. So notice we're only using x values. And the decreasing part is the part where the graph goes down, and there's actually two chunks where it goes down. Between the first max and the first min. So in between negative 2.6, negative 2.6, and the minimum was negative 1.5. And then it starts going down again after the maximum, the highest maximum. So that was at 0.3. And then that goes off to positive infinity because we're talking about the x's. When you do the rate of change is the y2 minus y1 over x2 minus x1. This one, it's kind of a dumb question because it has two answers. So you're going to have to do the y2 minus y1 stuff over x2 minus x1. So if we go y2 minus y1 over x2 minus x1, we just have to use all the decimals and put them in the calculator. I guess we could. I have the calculator right here. So from the maximum to the minimum, it would be 1.4 minus the minimum was negative 0.9. And then, so we're doing y2 minus y1 over x2 minus x1. So x2 is going to be negative 2.6 minus x1 is negative 1.5. So that stuff all goes in the calculator. So let me just type it in real quick. So ABC button first, 1.4 minus negative 0.9. And then on the bottom, we have negative 2.6 minus negative 1.5. And it's another decimal, which is fine. So it's negative 1.35. I'll just call it negative 1.4. So there's the first one. That's between this maximum and this minimum. So now we do the other two. So we do the high maximum and then the minimum again. So the maximum, I'll just say x1, y1, x2, y2. So what is it? y2, 6.9 minus y1, negative 0.9 over 0.3 minus negative 1.5. And again, that all goes in the calculator. So ABC, 6.9 minus negative 0.9. And then on the bottom, 0.3 minus negative 1.5. Another decimal, 3.88, so we'll just call it 3.9. There's your second answer. And that's all there is to it, guys. It doesn't have to be perfect, but we should have perfect numbers because we have the graphing calculator to help us. And I think there's another graph somewhere, but I don't know where I put it. Yeah, there's another graph, but I'm going to stop there because I hope you get the point. I'll be back on Thursday, so you should be able to ask me if you have more questions on graphing.